Welcome back. We're in lesson 21. We're going to talk about the product rule for exponents and the addition of like terms with exponents. So far we have learned with exponents that when we have a number and an exponent, that really just means to multiply it by that many times. So this would literally be 3 times 3 times 3 times 3 times 3. Now, fortunately, there's a button on your calculator that will do this for you, and we can go over that in class. Actually, I think I'll go ahead and show it to you now. Here's a calculator. This is a scientific calculator right here. This little key right here that says XY, let me clear this. This is your exponent key. So what you're going to do, you have the square and you have a cube here. This is when it's something other than a square or a cube. So you can type the number, and then you can hit this button, and then you can type the exponent, and then you hit equals. And it gives you the answer of 243. So let's check it and see, right? 3 times 3 is 9, right? 9 times 3, that's 27. 27 times 3. Oh goodness, that's a big number. I can't do that in my head. I need this. Let's do it here. All right, so we had 3 times 3 was 9. Times 3 is 27. Times 3 is 81. Times 3, 243. So all you need to do is look for this XY key on your scientific calculator, and you type in the number. You press the key, and then you type in the exponent that you want, and it gives you the answer. Easy peasy. Please use that. It's going to make your life so much more simple and expedient, and it's going to make you more accurate. That is why you're supposed to have a scientific calculator for this class. All right, so we know that these numbers multiplied together gives us, it's the same as 3 over 5. Well, here's another thing that we can do. 3, 5 is also equal to any grouping of these numbers. So if I said 3 squared times 3 cubed, it's the same as 3/5. So what we can do is we can understand that whenever we multiply constants, we can add the exponents if the constants are the same. Okay? If the constants are the same, we can just add the exponents together. So that means if I have 2 squared times 2 squared times 2 to the third, that's really 2 plus 2 is 4 plus 3 is 7. Same thing, okay? Easy peasy. If the bases are the same, then we can add the exponents together. Now, the same is true when we use variables. So if we use x's, we say x squared times x squared times x to the 5th. We can, if the bases are the same, then we can just add the exponent together and simplify it. 2 plus 2 is 4. 4 plus 5 is 9. So that would equal x to the 9. All the bases are the same, so we can combine them into one term, one expression here. Sorry, not expression, one term is correct. So I hope that you see how simple this is when you have the same base, then add exponents. Okay? This is our lesson for today. When you have the same base, add the exponents. All right, now we're going to look at a couple of problems and see if we can simplify them. Okay, so if you haven't written this down in your notebook, this is a really fine example for this. You need to put that in there. If I'm going too fast, pause and write it down, but I'm clearing the page. My computer is taking forever. Here we go. All right, now moving on. Let's start with example 21.1. And I'll walk you through some of these. So we are asked to simplify this term. So we have x squared, y squared, x to the fifth, and y to the third. Now understand, remember, when we have variables together, they're just factors. They're just multiplied times each other. So literally all this is x squared times y squared times x to the fifth times y to the third. And we also know, because of the commutative property of multiplication, that we could put these in any order that we want, and it would still be the same expression. Okay, it would have the same value because they are factors. So that means we can group them together. So let's group our x's. If we put x squared times x to the fifth, and we took our y's, we said y squared times y to the third. Now we can see them better. We have x to the 7 times y. If we add these together, that's y to the fifth. We don't have to have the multiplication symbol. We understand when we write variables together that they're factors and they're being multiplied against each other. So we can just write it like this. This is our answer. Okay? All we did was we looked for the bases that were the same, the matching variables, and then we added their exponents together. So we had an x2 and an x5. That means x7. y2, y3, that's y5. Okay? That's all we're doing. That is all we're doing. So let's move on to 21.2. 21.2 is a little bit longer. That's okay. We have x2, y3. Technically it's y to the third, m to the fifth, x to the third, and y to the second. All right, so we have a bunch of variables. Let's start by looking at what variables we have. We have an x, we have a y, we have an m, another x, and another y. So let's go ahead and just write this out. X, y, and m. Okay, let's start looking at the exponents for x. We have a 2, we have a 3. All right, for y, we have a 3, and we have a 2. My pen jumped around on that one, didn't it? Let's fix that. And then for m, all we have is 5. Now we can do the math. X to the fifth, y to the fifth, m to the fifth. And that is the answer. This is an easy method. If you would rather do it like this as opposed to grouping them together, you do what works for you. This way, you can kind of cross them off as you do them. I highly recommend that. And you keep track of all the ones you crossed off. You crossed off the x2 and the x3, the y3 and the y2, and all you had was the m5. So you keep track of what you're doing here. If you want to do it like that, feel free to do it, because this is correct as well. It's just another way to do it so you're not holding it all in your head. Okay? You don't have to hold it all in your head. God invented paper and pencils and calculators. Don't do it all in your head. Write it down. It will help you. Okay? I want you to write it down. I don't want you to try to show off by doing it all in your head, because, as the Bible says, pride goeth before a fall. We try to show out, we end up messing up. So let's do 21.3. we're going to simplify x, y squared, x cubed. Now, when we have a variable that does not have an exponent written next to it, the exponent is 1. Why? Because the factor is used one time. Okay? Whenever we had that problem that was 3 to the 5th, 3 times 3 times 3 times 3 times 3, this is 3 one time, 3 one time, 3 one time, 3 one time, 3 one time. 1 plus 1 plus 1 plus 1 plus 1 is 5. So every single time a factor is used, the exponent is just 1. So whenever you have a variable that doesn't have an exponent, if it helps you to remember, put that exponent of 1 right above so you can see what you're doing. So now all you have to do is write x 1 plus 3, okay, and that's going to be times y to the 1 plus 2, and now we know that that's going to be x to the 4 and y to the 3rd. Easy peasy. I actually like this method better than this method because it's just a little bit more clear. It helps me to see what I'm doing. Okay, whichever one you want to use is fine. This is the one I like for myself. Let's do another one. 21.4. These are kind of easy, don't you think? They're sort of fun to me. I'm a little bit geeky, but that's the way it is. It takes, a math geek to teach math, I guess. I don't know. That's the way God figured it out. So this is a pretty good long one. And this one is squared, and then you have x cubed, and then you have p to the 5 to the 5th power. All right, I want you guys to figure this one out yourself. So I want you to pause the video, work it out, then press play and see if you got the same answer that I did. Okay, let's do that. Go ahead and pause. All right, so you should have figured out that we have m to the 6, p to the 6, x to the 4. Now, if you don't have the variables in the same order that I do, it doesn't matter. What matters is that you have a 6 on the m, a 6 on the p, and a 4 on the x. You could have it in any order. It could be m6, x4, p6. It could be p6, m6, x4. It could be any of those, okay? And a whole bunch of other ones. You could have x first, x4, m6, p6. It doesn't matter. It doesn't matter. What matters is that you have these individual factors with the correct exponent. You need to have an m with a 6, a p with a 6, and an x with a 4. And if you have that, it will be marked right by me personally if the system doesn't catch it. Okay? Know that I am checking answers, and if it's just, sometimes I don't catch every possible variation and put it in the system. I'm a human being, I'm not perfect. But I try to get every possible variation that could be typed in so that the system will grade it more accurately. I'm still going to look at it. If I see that it marked it wrong, I'm going to look at it and make sure that it wasn't a system error before I let it be marked wrong. Okay? I want to give you all the benefit of the doubt and try to make sure that your grade is accurate. That is what I want, is for your grade to be accurate so you know how well you understand what you're doing. That's what your grade is supposed to do, is give you an understanding of how well you're mastering the material. All right. So let's move on to 21B. And in 21B, we're going to talk about the addition of like terms with exponents. So I'm going to clear the page. If you need more time, then go ahead and pause the video and write it down. I'm clearing the page now. So this is the second part of lesson 21. We're talking about the addition of like terms with exponents. And all that means is we're going to have more than just variables. And they're not going to be multiplied by each other. They're going to be added together. So we're given a sample problem here. 3x squared plus 2x squared equals what? Well, we have coefficients, constants here, and we have bases here, and we have an exponent. That means that whatever x is, it's squared. And that value is a relationship, or that relationship has a real value. Whatever x is, it's squared here. And it's going to be multiplied by whatever this constant is. We know enough about math to know that if we have like bases, we can add them together. So if this was 3x plus 2x, the answer would be 5x, right? We know that already. Well, when they have the same exponent, it's the same relationship. It's kind of like having the same denominator. It's very similar to that. It's like this is a denominator, and it has to match exactly before you can add your constants together. So with these having exactly the same variable, x squared and x squared, we can add them and say 5x squared is our answer. When you understand that, when you look at it, it makes perfect sense, okay? You have 5 things that are multiplied by x squared. You had 3 things that are multiplied by x squared, and you had 2 things that are multiplied by x squared. Well, that makes a total of 5 things that are being multiplied by x squared. So you have to think about it in terms like that. So here is a sample problem for us to do, 21.5. And we are asked to simplify this problem. And it's kind of long. So I'm going to pause and write. Okay, now that I'm back, I've written all of these out, okay? This one's kind of confusing. It's pretty long. The big thing that I see here, or the thing that will help you the most, is to rewrite this with the exponents, not the exponents, I'm sorry, with the variables in the same order, and that order, the easiest order is alphabetical. So let's do that. Let's rewrite everything in the same alphabetical order so that it's easier to see if we have like terms or not. My daughter is cleaning the kitchen right now, and she is being very, very loud. I don't know if you can hear those pots and pans banging around. I think that's her way of saying she doesn't like cleaning the kitchen. Oh well, we all have to do things we don't like. All right, so here we go. So now let's compare. Let's see what we have. We have P5x squared y. Do we see another one like that? All right, here's one, P5x squared y. And that's it. All right, these are the only 2 that have an x squared. So what's our constant with these variables? Well, for this, there is no constant. Well, when there is no constant, the constant is 1. So put that in whenever you see just a string of variables together to make a term. You can add 1 because 1 times anything is itself. So the invisible 1 always works. But that helps you do the math better. So now you have 1 plus 3, and these are exactly alike. So that's going to be 4 P5 x squared y. And now we have to look at this one. We have P5x y squared. And we have 2, and we have -7. So the signs are different. +2, -7. The difference is 5, and the 7 is negative, and it's the bigger number. So it's going to be a -5 P5 x y squared. and we've got all of this simplified as much as possible. The variables and their exponents have to match exactly. If they don't match exactly, you cannot combine them, because then they are different factors to different powers, and they will have a different value. Just because they're the same letters, that doesn't mean they match. They have to have the same exponents. Okay? All right, let's do 21.6. And this one is a long one as well, so I'm going to pause and write it out for you. And then I'm going to, just to save a little bit of time, I'm going to let you do it. All right, so here's the problem. It's a long one. There's 4 terms here. They're 4 big ones. And this is next. Sometimes my pen doesn't do what I want it to do. All right, so I want you to pause the video and combine the like terms and simplify this as much as possible, and then press play and see if you got the same thing that I have. All right, so the first thing I did was I rewrote everything in alphabetical order so that I could see what I had and compare it accurately. So for the first 3 terms, I have m3pxy squared as my variable combination with my constants. So that means I can combine the first 3. So I had positive 2, positive 3, that makes a positive 5, and a negative 10. That leaves a negative 5, m3pxy squared. And then this last term, which is all by itself, so I brought him straight down. That's all you had to do for 21.6. All right, we'll do one more. Pause if you need to finish writing. I'm going to clear the page. Press play when you're ready to move on. All right, 21.7. This is the last problem of the lesson. I know you're happy about that. This is not a terribly long one. It doesn't have just tons of variables on each one, which is great. It makes it a little bit easier to figure out. But they did give us a plenty terms to try to figure out in the process. All right, so we have our terms written down. At any point when I'm doing these videos, if I'm going too fast, just press pause, finish writing, catch up, and then press play. Okay, so if I write faster than you and I move on to the next step, just pause it when I finish writing the problem, and finish writing it yourself, and then press play, and we'll move on to the next step. Pause it at the end of each step if you have to, okay? So the first thing I'm going to do is I'm going to evaluate my variables, and I'm going to make sure they're all written in XY, because that is alphabetical order, and it's just easier to see if they're the same if they're written in alphabetical order. Just make sure you get the exponents written in the right places when you do that. Alright, so I have x squared y to the 1, x squared y to the 1. So this one and this one match. Do I have another x squared y to the 1? I have one here, and that's it. So I have those 3. Now remember, when you have no constant in front of your variables, that constant is 1. And you can just put that 1 in there to make it easy to do the math. So I have a positive 2 and a positive 3, so that's a positive 5, and a negative 1, so that's going to be 5 minus 1 is going to be a positive 4. Bring down my variable combination. Okay, now I have x squared, y squared, x squared, y squared. And again, we put in our imaginary invisible 1 to help us do the math. So we have a positive 1 and a negative 4. So that's going to be a negative 3 x squared, y squared. Pretty easy peasy. All right, guys, that's all we have for lesson 21. I'll see you in lesson 22.